Take your seats, please, so we can move on to the next talk. Next talk is Ryan Lippert from Cloudera, and he's going to talk about big data analytics in the cloud. Right?
Thanks, Max. And just thanks to Cask in general for hosting us and inviting us to speak. Really appreciate that. So as Max said, my name is Ryan Lippert. I'm in product marketing over at Cloudera. And today we'll be going through Hadoop in the cloud and what you can do there, what makes sense from a configuration standpoint, and just a general framing for how you should be thinking about doing big data and analytics in the cloud. So is everyone familiar with what Cloudera does? More generally, we're curators of Hadoop. We help move it forward more generally. We've got a decent amount of funding to date. I'm trying to figure out how to get more of that $670 million in my pocket. Doesn't seem to be working so far. And so today what we're going to go over, it's definitely a complex topic that people, not just in Silicon Valley, but pretty much all over the United States and the world are trying to comprehend. And that's what is going on here. Not too sure. But being a little more serious, cloud computing, it seems to be a direction that just about everybody's moving in some sense or another. And it might be something to do with corporate mandate. It might be that that's actually a way for you to decrease cost. But it's happening. And you can see with the growth of AWS, the growth of Azure, that in Google Cloud Platform as well, that it's happening. And it's a matter of how's it going to happen, how are we going to transition to it, and what makes sense. Now, at the same time that that's happening, we're in the middle of a bit of a big data revolution from a Hadoop perspective. And it's not just a matter of now that we have these processing tools to be able to do this, but IoT and sensor data and just data in general, whether it's structured or unstructured, is coming faster and faster than it has been in the past. And so we need platforms that can take that data and analyze it so that we can actually get something out of it, as opposed to it just being something that goes and lives on tape somewhere in storage that nobody ever looks at again. And so when we look at our customers and we see what they're doing, it primarily revolves around three different areas. And another one that I wouldn't show here is just modernization more generally, kind of saving money through doing that. But we're driving customer insights. So that's really a matter of getting to know your customers better, getting to know what products they're using, how they're using it, and what they're buying. You can just really do a better job of cross-sell, upsell, whatever it might be. The next one is improving products and services efficiency. So that's really looking into your products, understanding how they're being used, and then from there, improving them so that the features that are being used heavily, they're easier to use and you can put more engineering focus on that. And the final piece of things is lowering business risk. And these are all done strictly through data. And I think that you can now see companies very specifically that are doing that as their business model. So from Uber, really what they're doing there is just driving a better product. It's a better product than what there was in the past, and it's a product that's totally driven by data. In the past, you wouldn't have had a way to show, hey, this is the data point of where I'm at, here's the data from where the drivers are at, and then to connect that. Couldn't do it in the past. Airbnb, it's the same thing in terms of what Uber's doing, connecting people who've got houses and people who need to rent something. But they also do a lot from a risk perspective. And that's what makes that platform successful. It's different than just renting something off of Craigslist. They help mitigate risk there as well, and they do that through data models. When you look at Facebook and Spotify in particular, what they're really doing there is they're driving customer insights. And so Facebook, the platform that we engage with on a regular basis, the consumer end of it, we kind of see what our friends are doing, and then, we see how they complain about Hillary and Trump. That's kind of what you get out of Facebook. But from their perspective, they're trying to sell ads. And selling those ads is all about knowing your customers better and having insight into those customers. And the same thing goes with Spotify. If you guys use Spotify or Pandora, it's great to get this, special playlist that's curated just for you. It's like getting a mixtape dropped off from, your high school crush or something like that. They know you better than, you might even know yourself. And so what that shows is just that our relationship with data is changing. And so as our relationship with data changes, and as the way that we're housing this data changes, we need to think about how Hadoop and the cloud come together. So the first thing to think there is, well, what's actually driving that? And so I think that, there's good reasons, there's bad reasons, but there are reasons all the same. There are, things that we need to deal with on a regular basis at work. So sometimes it can just be an executive mandate. There might be someone who's up in the technology organization in IT that just says, we're going to be moving to cloud, and that's the bottom line with this. And so look at what you're doing currently and get a plan together so that we can move this up and off of our premises. That's one way this goes. A lot of times the reason why there is an executive mandate is because there's a perception that there's going to be a lower overall total cost of ownership. Now, that's a claim that maybe in the long run is going to be true, but right now that's not the case necessarily in all cases. But either way, if you want to test the water so that you can eventually move towards a cloud environment, you've got to start somewhere, and so there's that mandate coming down. Increased agility is another big piece of this as well. If you can spin up and spin down clusters, you can really start to take use cases and move a lot faster with them in the cloud than you would be able to do on-prem. You know, we've worked with some customers that take 3 to 6 months just to get a proof of concept up and moving, because they need to provision the hardware, they need to wait in line for their resources, then they need to be able to test out the concept, and then from there they need to operationalize it. If instead of doing that and waiting for that internal IT to spin up, if instead you can move to the cloud, then all of a sudden you're actually able to take those use cases, figure out and iterate on which ones are successful, and move to that a lot faster than you would be able to if it was on-prem. And then finally, I mentioned this earlier, but just elasticity. So if you're going to optimize your infrastructure usage, it's really great to be able to burst on and burst off depending on what those workloads look like. And so what that all points to, from our perspective, is a real need for hybrid is the option that you're looking at. It's very rare that you're going to move totally to the cloud. At this point, there's not many organizations that are exclusively on-prem either. And so what you see is a model where you need to have a hybrid of on-prem, in the cloud, and then the ability to move back and forth between them. And so that kind of puts you already at a point where you're really making, you need to make conscious decisions about how you're going to deploy software and what infrastructure you're going to use alongside that. And the big thing that can come through there to protect you in the future, whether it's contract negotiations, that can make it so that you've got a portable data center, is using someone who isn't necessarily tied to an on-prem distribution or a public cloud distribution, but someone that gives you portability between them. And so obviously, I'm from Cloudera, that's our pitch, is that you need to be able to move between on-prem and in the cloud, but not just on-prem to the cloud, but it's important to be able to move between different cloud distributions as well, because that's really going to put you in an advantageous position whenever it comes to negotiations. So when we look at common workloads in the cloud, what do those look like? Well, we kind of break it down into 3 major areas here. The first is reducing operating costs. That's an easy win if you can put together a strategy for how you're going to reduce operating costs. That's always going to be to your benefit. New insights and new revenue is another way that another reason why people are going to end up going to the cloud. They can get, as I mentioned earlier, they can move through and iterate faster than they were able to in the past, get to those new insights, and then drive revenue before their competitors can, and potentially box them out as well. And the final piece of things is running without risk. So there's always risk internally, and not to say that when you move to the cloud there isn't risk there either. But one thing that you can do is you can make sure by moving to the cloud, just to continue with the Trump and Hillary jokes, I know that this morning servers in Canada for immigration crashed. Now, if they had the ability to spin up and spin down based on the kind of traffic that was coming to their site, they might have a few more Canadians in the pipeline. Never a bad thing. So that's another way that you can think about running without risk. So let's dive into each one of those, and then also just kind of walk through some use cases as to how this actually happens in practice. So when we think about reducing operating costs, a big piece of that is just pay for what you need and pay for that when you need it. When you think about having all of your work done on-prem, it's almost like the same situation that we end up into when you think about the power grid. So the power grid has to be able to supply power for whatever peak power is. Now, that doesn't necessarily mean that you're very rarely ever at that peak power. Maybe it's whenever it's, the middle of summer, everyone's running their air conditioner during the middle of the day. But you've still got to be able to scale up to that. Now, if you have the ability in that industry, which you do now have within computing, to be able to say, well, let's plan for what, the 80th percentile is, or you pick your number based on what you're comfortable with. And then from there, we can scale up and scale down within the cloud. That really helps a lot in terms of you controlling your overall cost, because you're not dumping all of that extra money into infrastructure. And not only that, but if you're dumping that money into infrastructure that's very rarely utilized, you're also, cementing yourself right now in 2016, and when that infrastructure gets renewed in 2018, 2019, whatever it might be, you could have ended up with, just like buying a flat screen TV. You wait a few years, you get a much better one. Same kind of story here. So an example of this, and this was us working with Navantis, specifically with AWS. What Navantis does is they'll go through and they'll help banks better understand their customers. So they like to talk about something called, everybody's familiar with the 360-degree analysis. They call it a 720-degree customer view. It sounds like a snowboard or skateboard trick, but the way that they think about it is 360 degrees is what you get from looking at all of the data within your company. So that's all the interaction that you have with your customers. Now you can get another 360-degree view of that customer by looking at what they're doing online and socially. So as you guys think about even just how logins have changed recently, where you're not creating a new username for every website that you go to, but rather you're putting in your email address, or you're connecting it with Facebook, you're connecting it with Twitter, and that's a lot of times how you log into your own consumer sites now. What that's allowing folks to do is just get a better idea of what you're doing overall as a person out there, and what you tend to like. And so you can kind of look at that from a big brother perspective, but then you can also look at it from the perspective of these companies just want to serve you better. And so by knowing you better, they can actually serve up better products to you and tee up things that are going to be useful to you. So for Navantis in particular, what they were having an issue with is that spike. So there were certain events where it would increase the amount of social data that they were streaming. If there was market data coming in, some type of event that would have happened in, whether the financial crisis or something similar, that leads to serious spikes in terms of what happens on their traffic. And so then they had to plan for capacity to be able to take that in, or else they'd lose hours and hours of potentially very important data. Because whenever an event happens, it's typically when your customers are going to give you more insight into what it is that they're thinking. On an average day, there's not a whole lot going on, but the Cubs win the World Series, and then all of a sudden you get a lot of insight into, do you have a sports fan here, or is it not a sports fan? So that kind of insight is what they're able to now drive, and they're able to actually, through that, reduce their marketing costs by over 50% and focus specifically on high potential customers. So it sucks to chase a customer that isn't ever going to pay you back or get you to net neutral from what the acquisition cost is. By being able to bring big data and bring it together with cloud computing, which allows that flexibility, you're able to keep costs down while still going after those customers that are most profitable. And so we were able to do that with Impala, specifically with Navantis, by using a combination of Impala Spark and then also Cloudera Director, which makes it really easy to deploy a distributed cluster in the cloud. So moving the next step on, just in terms of new insights and new revenue. So BI and analytics, that's really the heart of Hadoop and what people think of as the traditional Hadoop use case. You have a lot of information, and then you're going to move through that information to try to figure out patterns and be able to analyze what's going on with your customers. And so from a cloud perspective, what that allows us to do whenever you bring Hadoop and the cloud together is really to be able to size to the demand that you have internally within your own data customers. So if you look at the folks, your business analysts, you look at people who are running through reports and being able to, wanting to consume that data, you're able to scale up and bring in new types of data faster than you would be able to in the past, because you can scale up to that storage almost immediately. As soon as you want to do it, you can go for it, as opposed to having to actually roll out this equipment on premises whenever you want to capture a new set of data. The other thing that allows our customers to do is just be much more agile in terms of iterating through whether or not this is a data set that's even going to work. So rather than having to buy the infrastructure and then do the testing to see whether or not that infrastructure was even worth buying because you don't know if that new data was helpful, you're able to do that all in the cloud. And then if you need to, you can bring it back on premises because that might be a cheaper option if you're now consistently running or streaming that data. Which is another reason why it's important whenever you think about how you're going to run big data, is to have that portability that goes up to the cloud and then back to on-prem, or even between clusters in the cloud as well. So to go through another use case on that, a big one for analytics for us is GoPro actually. Everyone's familiar with it. You can strap it to your dog, you can strap it to your surfboard. Makes for great pictures and great video. And so what GoPro wanted to do was they wanted to be able to measure the interactions across the ecosystem so that they could get a better idea of where they should be involved and what they should be doing with spend. Now, from a GoPro perspective, they designed their product for video. You can see any of the commercials they put out. You can think about any kind of the products that GoPro just generally goes with. It's a video kind of product. What they actually found out by going through and analyzing the way that users were using their products was that people take a lot of pictures with GoPro in addition to taking video. And that was something, it was always a feature, and why not? If you can take video, then make it a camera as well. There's no reason to not put in that feature. But what they didn't anticipate was that so many people would actually end up using that, and then that would be a big way that people were sharing online. And so by being able to get that insight into their own product, something that you think you would know, but when it's distributed across so many different users, it's actually hard to see that. They were able to then take the features that they were working with from a social perspective, which is part of the GoPro platform as well. They want to make sure that as you're capturing video, taking pictures, whatever it might be, that you're then incentivized to share those. And then from sharing those, other people will say, boy, what a cool GoPro video or picture. Maybe I should go get one of those devices. And then they share, and you end up with a virtuous cycle. And by better knowing that people do take pictures with their GoPros, what they're able to do is then change the platforms and the editing tools that they use to better work with pictures in addition to video. By doing that, you end up with more users sharing more photos and more video, which then leads to more product sales. And they were able to do all of that because they were able to, dramatically change the way that they were looking at their data. And without using the cloud and Hadoop together, this might have been a step that they didn't take because it was something that they would have had to then, install new servers on-prem, buy new compute, invest in infrastructure. With cloud, you can get up, you can test it quickly, and then you can move forward with it. This was real-time streaming is how they actually went about this, and they used Kafka and Spark streaming in particular to be able to take this forward, which then threw to HDFS to then put Impala on top to do the large analytics scans to actually find out what was going on with their customers. The final workload that I want to talk about is app delivery. So this is really running without risk and making sure that you're always up and moving. So it needs to be enterprise grade. It's got to protect your business no matter what. So that's really looking at moving to the cloud as a manner of extending what your business looks like, making sure that things don't run offline. So the example that I'll run through for this is FINRA. So FINRA is a regulatory agency that kind of spies on Wall Street, makes sure that everybody's playing at least as nice as we think that Wall Street typically plays. So what they're doing is processing up to 30 billion market events per day. Now we talked about the issues earlier in terms of being able to scale up elastically whenever you're talking about only on-premises compute power. Now, whenever you're talking about financial markets in particular, you have a wide swing in terms of how many people are executing trades on any given day. So, again, back to Trump and Hillary, you could see even last night that markets were moving as these results came in. So a day like today is going to be a much heavier day for futures, for options, and just for general trading than, let's say the day after Christmas would be. And so when you have this huge variance in terms of how much you're doing and what you're doing on a daily basis from an ingest perspective, you need to be able to use an elastic cloud to be able to take that on. And so when we look at FINRA, they were actually able to save around $20 million on an annual basis because now they can scale as needed. They can actually look at the overhead that they've got in terms of capacity management that they were doing in the past, taking some analysts offline, putting other analysts offline based on what kind of information was going across the wire on a daily basis. That's a lot of complex work. Now, because they've moved to the cloud, everyone can access that data at any given time, and they can also now run on standard x86 servers or whatever the baseline offerings in the cloud are. Whenever they were using on-prem and proprietary technology before they had moved across to HBase, the addition of small amounts of capacity was prohibitively expensive. And so all that work trying to manage, okay, it's almost like when you've got 5 roommates sharing one bathroom. Who's going to get it? Who's going to get it when? Well, when you move to the cloud, it's like you've got bathrooms on demand. Everyone can use it whenever you need to. So that's one way to think about it. So we kind of moved through a lot of the different use cases that you can see here, but bringing it back around to what are the key requirements of big data in the cloud, and not even just key requirements, but what are the reasons you'd move to the cloud? Well, Elastic is a big piece of this. When you can grow and shrink on demand, that is a huge advantage to the cloud, a huge advantage. you want to be able to do hybrid and multi-cloud environments. So you need to be able to move from on-prem to the cloud and then back to on-prem so that as your requirements change and perhaps that executive mandate that you move to the cloud, regulations change in your industry and then all of a sudden you need to move everything back on-prem. Or perhaps, regulations change within the country that you're in even, and then you've got data sovereignty issues that you need to work with. Well, that again then means that you need to be moving your data around. So as soon as you marry your data to one or another of the cloud providers, you're a little bit stuck with them, and the cost of switching increases dramatically. Whereas if you have your data housed and your data architecture done in a way that you can move between on-prem and different clouds, that's just going to make your life a whole lot easier for a few steps down the road. The final thing is just making sure that what you're doing is enterprise grade. So I think that that's just table stakes for almost everyone in here. You don't want to be messing with things where your data can leak. That's front page news kind of things these days. So that's really table stakes. So how do you Hadoop in the cloud? We've talked a lot about kind of the concepts to it, but let's get into some nerd charts and actually talk through this a little bit more. So the first thing that you want to be able to do is decoupled storage and compute for elastic scale. So that's really a matter of layering on top of, you can use object store, whether it's S3 or anything that you want to use. Azure kind of works the same way. You need to be able to go up and you need to be able to go down. You need to embrace transients for lower costs as well. Again, it's just a matter of spinning it up and spinning it down, and you can do that fast enough now that it actually doesn't affect your operations. In the earlier days of big data in the cloud, it took so long to spin up and so long to decommission that you were paying for that capacity as you were decommissioning, and then the ability to spin up took so long that if you were trying to do this on demand, it's one thing if you can plan for it, you're a Target or a Best Buy and you know that you're going to have an increased demand on Black Friday. That's great and that's easy to use elasticity for that. But then if you're a trader and you don't know necessarily what's going to move the markets one way or the other, that needs to be very fast, and that's where we're at right now. And then finally, you can also get to a point where you've got compartmentalization for greater isolation. So that means that, whether it's you don't want necessarily the data to be shared across different folks who are using it, if you want to make sure that the resources are committed to specific applications, you're able to do all of that in the cloud. So when we think about, cloud and when we think about big data just in general, there are two different kinds of applications that we look at. There are persistent applications and then there are also transient applications. And then those can also come together to create a Lambda architecture. So let's step through those three different things, but let's first look at a persistent application and talk through that. So when you think about anything that's a streaming architecture, anything where you're bringing in data in real time, if it's real time, it's by definition always on. That's going to be a cluster that is always moving. And so the way that we typically would see it, that play out is whatever kind of data source you have, that can be brought in through Kafka, Flume, or even through Cache Hydrator. That's another way that you can move things in as well. We look to drop that off into Spark Streaming, which can then push it across into the data store of HBase, or even Kudu with Impala on top of it. And I'll have a little bit to say about Kudu after I talk about the Lambda architecture. That then enables real-time serving in a kind of an operational database type way to whatever your application is. And so if you're FINRA and you need to be able to investigate a certain set of trades that have happened, you can get that information extremely quickly because it's all been streamed in and it's available for you in real time. And whether you do that in the cloud or on-prem, it works either way the same. Now, when you talk about persistent applications, that's again an area where you might want to look more towards using the cloud for that, or using on-prem equipment for that. Because if it's always on, it's typically going to be cheaper to do that on-prem than it's going to be to do it in the cloud. Because you pay extra, you pay a premium for the ability to spin up and spin down. So let's look at transient applications. So this is going to be whenever you know that you're getting a burst of data. So it could be every Tuesday at noon, you know that you have some kind of invoices that go out or invoices that come in. You know that it's going to happen and you're going to be able to do batch analysis on it. So that's a matter of just taking the data sources, streaming that into S3, either for, by Hive Spark or Hive on Spark. And then once it's in S3, you can do any kind of BI and analytics that you might want to do through Impala or even through Spark as well. That'll work too. And then that gets served out to your application. So this is really then processed data. This is when the analytics have been applied to it, which is a lot different than the previous slide, which is just a matter of pushing the data through. Now, there are times as well where you want to actually not just have real-time data available or just have analytics run on what would be batch data, but you want to actually combine those two together into a Lambda architecture. So a Lambda architecture is the big data workaround for what's kind of the gap between HBase and HDFS. HBase will give you really fast, kind of read writes. HDFS gives you really fast scans and analytics. But there's a gap in between, and the Lambda architecture is a way to solve that. And so what you have here is the data streaming in, which then periodically gets archived down to S3 in this case. And then from that S3 data repository, you can then run analytics on that as well. And so you're able to kind of get the best of both worlds. And by using compute and by using S3, you can decide whether or not you want to be running analytics on it. So if typically what you're doing is, running an application where it's just a matter of getting quick answers to, what has happened in the past, more of an operational use case, you might say, well, boy, I've got an inkling that, X, Y, or Z is happening within our operational data. And I think that if we did this, we could, save money, we could reduce costs, we could increase profitability. But you've got no way to really test that. So if you burst up to the cloud and actually drop some batch information in there that you can then go and run queries on, you've again extended what your essentially what your data center is to be able to actually take on new use cases, improve new use cases before you put the infrastructure investment into them. Now, one thing I'll say here is, kind of a plug for one of the new open source products. So when we look at Kudu in particular, one thing that Kudu allows us to do is circumvent the need for a Lambda architecture. So when you had the previous paradigm of HBase and HDFS, there was a big gap in the middle there. So if you wanted to do fast scans on fast data, so basically real-time analytics, as opposed to just real-time serving, you weren't able to do that without a complex architecture. And there are different spaces where an architecture like this can fall down. You might not necessarily have the most up-to-date information within your batch, and that can create an issue whenever you're trying to look at analytics and try to make decisions on the fly. With Kudu, that actually kind of takes and plugs that spot between HDFS and HBase, and that allows you to actually do the analytic scans on data as it's coming in real time. So it's a new paradigm that 1.0 for that just went out in September, and we at Cloudera hope to be supporting that in our general distribution sometime this year. So we've talked a lot about the cloud and how great this is and all the different things that it's going to enable for you, but a big question there as well then is, okay, well, how do we get things up and into the cloud? How do I get this working? Is it difficult to move the distribution forward? Well, with Cloudera Director, we make that as easy as possible. There's easy distribution for it, so you can get things up and moving as fast as you want. You can automate things there as well. The deployments are totally flexible. You can move between different clouds. You can move between on-prem and in the cloud. And we support all the AWS, Microsoft, and Google Cloud Platform as well. And then finally, it's enterprise grade. So, we've got integration across Cloudera Enterprise. So anything that you're used to getting from Hadoop on-prem, you can now get from Hadoop in the cloud. And that gives you maximum flexibility when it comes to processing your data. So what you can actually do as well, kind of as a close here, if you look at both AWS and Azure, they've got programs, and we've got programs with them where it's really easy to deploy this quickly so that you can get a flavor of it and get a test of, okay, well, what does it feel like to run in the cloud with this? And even if you're just thinking about, potentially taking on big data to start, the cloud is a great place to start for that because that means that you don't need to go through all of the same proof of concepts that you have to go with on-prem installations. And you can move faster, you can prove your use cases and get a taste for it, and then potentially bring things on-prem. It's super flexible and can work any way that you need it to work. So that's my time. Happy to take any questions either now or at the next break.
So how do you differentiate between this topic and somebody like Modelworks or Database?
Yeah, so when being a meetup, don't want to necessarily get too deep in with my competitors. But what I'd say is, as you look at what Cloudera can do in the cloud, I think that with Cloudera Director, we make it easier to deploy in the cloud than our competitors do. It's a tool that is specifically built for Cloudera's distribution, which means that it's not a, sometimes I think whenever you look at the management tools that go along with Hadoop and that are open source, those need to be one size fits all because they need to be able to take any distribution and work with that. And so the way I sometimes think about that is if you took an extra large t-shirt and that was kind of the way that you worked with things, that t-shirt is going to fit everybody. And so it's going to work, it's going to keep you clothed, it's going to fit everyone. But if you then, there's a reason why we don't all walk around with extra large t-shirts on. You get a t-shirt that fits your size, and as such, I think that you should be using management tools that are specific to the distribution that you're taking forward. So I'd say that from an ease of use and moving in the cloud perspective. Then whenever it comes to just the distribution itself, I won't get too into that because I think that it's, with Cloudera, all the same functionality that you have on-prem, you also have in the cloud, and so I would just point back towards the same differentiation that we feel that we have on-prem, which is that we're faster, we're easier to use, and we're more secure. We have more developers and more committers into the projects that are seeing broad adoption. So, some of our competitors might have more projects in flight, but it's Steph Curry being the MVP of the NBA, which is a broadly accepted sport, is a lot different than you saying, you've got a hybrid between ultimate frisbee and soccer that you're the best player in the world at. So I think that when you look at those open standards and you look across the board, Cloudera is kind of leading the innovation there, and leading that innovation gives us insight into what's coming, both right now and then down the pipe as well.
Good question. So are you supporting some sort of functionality of moving easily the data, let's say, in a hybrid environment? So let's say a mix of on-prem and AWS or Azure. Do you support that too or not?
Yeah, we do support that, and I think that that's a big piece of what the advantage in moving to the cloud is.
Can you build like a life cycle for that? You can do that.
You can build a life cycle, and I'd say that as I look at the cloud in particular, and what so the flip side of that, I guess, would be is what if you could only stay in the cloud or you could only be on-prem? I think that that's the crux of why you would want a third-party vendor to come in and help you with this, is it gives you that portability to move between the two. If you were convinced that you always wanted to stay in the cloud, I think that I have a strong story as to why our tools are better, but it's not nearly as strong as the story that goes along with portability and the ability to pit vendors against each other for future price negotiations. Vendors do different things in terms of what their development looks like going forward. They might pick different niches to appeal to, and your ability to move not just your data, but then the pipelines that you've built around it, which are, that's the real difficult piece of things. You have complete portability when it comes to Cloudera.
Sure. Thank you.
Sure.